Hi there. So we're continuing our simulation, our experiment and simulation for sampling distributions for a proportion. So the distribution of random samples for a proportion. And this one is a little different app because it uses a proportion instead of a mean. So here what I need to do is go to Edit Proportion. And I'm going to put in, actually I already did, put in the one that we used in our experiment, which was 0.625. That way we can see, by doing a lot more samples, we can see what the histograms should look like. And then you can also adjust your sample size here. So I'll start with, well, let's just for fun, let's just start with the 2. And see if we did a lot more than 10, what we would come up with. Now I need to just adjust my window here because it's not quite all showing. Okay, I think I'm going to need to move it down. It's not getting any smaller for me. So I'll just move it down after I show you what I'm doing at the top. Okay, so I can generate one sample. And what that does is it shows you over here. So this is out of pulling 2 people out of the bucket. And 2 were yes, and so that's 2 out of 2, which is 1.0. So let me move this down, and you can see there's a dot right there. Okay, maybe I can keep it here. So I can generate one more, and what you'll notice is the scale moves around. So that dot that was on the right is actually now over here. This one, interesting. It's still saying the original one. Okay, here's one that says 1 said yes out of 2 for a proportion of 0.5. So you can see instead of squares, they're little dots on this one. And now I can generate 10 at a time, or I can do 100 or 1,000. Okay, this one will hang up if you press it if you do too many too fast. So don't click super fast on this one or it'll get stuck for a while. Also, see this little triangle? This gives our average of all the sample proportions, and that's 0.626. So that's pretty close, right? I'm just going to do a couple more until it looks like the graph isn't changing anymore. Now, when it jumps around, just notice that sometimes the scale at the bottom is changing. They might also be, oh, sorry, this is 2. We did 3. So this one only has options of 0, 0.5, or 1. Okay. Look at this shape. It's a little higher in the middle, but then it might be, looks like it might be skewed. So let's go ahead and do 3. Move my window up a little bit. Let me change this to sample size of 3. Do a bunch. Okay, so this is the first graph I did. And it's getting taller because just the frequency is going up here. Okay, so if we had kept going with the 3 out of the bucket, this is what it would look like after 4,321 samples, okay? And we've got 0.624, so that's pretty close to 0.625. Okay, so this to me looks skewed to the left, kind of symmetric right here, but then we've got this tail over here. So this is skewed to the left. So let's get more bars. Let's do the 5, and then we'll increase it. Just gonna go right to 100. Okay, so a few more bars this time. We're still not getting 5 no's, so that tells us there's definitely more yeses than no's. So it looks like it's probably getting a little narrower, but still not symmetric. So let's try a bigger number. Let's try 25 this time. Interesting. Okay, so this looks a lot more symmetric. Now we're taking a survey of 25 people, saying, were you born in Oregon? And then these are the possibilities of all the random samples, okay? Notice our scale goes from 0 to maybe 0.9, because this is 0.85 right here. So we want to look and see if, like last time, is it getting narrower or not, okay? So let's look, and we have our 0.624 right there in the middle. It's looking pretty symmetric. Let's see, do I have a normal thing on this one? Can't remember, I don't see it. It might be there, I'm not seeing it. Let's go up higher. Let's try 50. And you can see it takes a while for it to get symmetric because of just usual variation within samples. Okay, this one is looking maybe a little more normal with these tails. And notice this one's going from 0.4 to 0.85. Can't remember if that might have been about the same as the last one. So let's increase it even more. Let's go up to 100. Okay, so this definitely has a smaller standard deviation because look, it's now going a little less than 0.5 to a little more than 0.75. So it definitely is coming in a little bit. And then if you think of a typical poll, a political poll is usually around 1,500 people. So let's do that one. Let's see what happens. 1,500. And remember, each dot is 1,500 people. Wow, okay, so it's not quite normal yet. I need to do some more samples. It's taking this one a little bit longer time to do. So for example, this particular sample, 950 people were born in Oregon out of 1,500. That's a sample proportion of 0.633. Overall, our average is 0.625. So we are getting the actual population proportion as our mean. Okay, so that's important. And then we're going to have a formula for our standard deviation, just like in the last one. But see how, even though the window size isn't changing, the scale is changing. So now we're going from 0.58 to 0.66. So that has come in quite a bit. Okay, this is how we get our plus or minus estimations when we take surveys. Okay, but the mean is equal to our population mean. Okay, so I hope you found that interesting. Feel free to play around with it, and I will summarize this in the next video on our notes page. Okay, see you there.